Welcome to Lesson 11 of the DB2 on Campus lecture series. We're going to talk today about concurrency and locking. My name is Raul Chong and I'm the DB2 on Campus Program Manager. This is the first lesson within the application development part of this course. This is the agenda for today, and we will start with some concurrency and locking overview. There are some basic concepts that we will talk about in the next few slides. The first one is, what is a transaction? If these topics are too basic for you, you can always move forward to the next few slides. Okay, a transaction could be better explained using this simple example. Let's say you have two accounts at a bank. One is a savings account and the other one is a checking account. In the savings account you have a balance of $1,000. In the checking account you have a balance of $200. Now, let's say you want to transfer $100 from savings to checkings. Behind the scenes, probably what's going to happen is you will have to debit $100 from the savings account, and then you will have to credit $100 to the checking account. Now, what's going to be the problem here? What happens if you first issue a debit of the 100 from the savings account, and then all of a sudden there is a power outage and the operation is not completed, is not able to complete? So you basically took 100 from the savings account, but you didn't put the other 100 to the checking account. So you just lost basically $100, right? Now, in a bank or many operations in many industries, these type of situations could not happen. I mean, you basically have to treat this as one unit. So this is a transaction, basically treating several operations or several maybe SQL statements as one transaction, as one unit of work. So a transaction and the unit of work is equivalent name. Now, this is a brief introduction to concurrency. So let's say there are several applications, application B, C, and D, A, B, C, and D, trying to access the same row in the same table. Now, if there is no if there's no control, then you may have the application A is doing some maybe update, or maybe let's all of these applications may be doing an update on this same row. So at the end, what would be the final result? It would be hard to tell what would be the final result if there is no control, right? But concurrency in general means that several applications can work at the same time on the same database or same tables on the database. Now, in terms of control, for allowing a consistent way to do concurrency, or a way that there is integrity in your data, you can use locks. Right? So, for example, in this case, you can have the same applications, but this time application B is the one who accesses, let's say, the second row first than everybody. So this application A took a lock on that row, right? So that's when a lock can help to allow for concurrency, but at the same time allow for integrity of your data. So now that application B is holding the lock, the other applications basically have to wait until this lock is released. Okay, so that's just a very brief introduction or concept on concurrency and locking. And now we're going to talk about concurrency in a little bit more detail. So concurrency is designed for allowing users to access a database simultaneously, so several applications can work on the same database at the same time. And there are several problems that can happen if there is no concurrency control. So the four problems that can happen are lost update, uncommitted read, non-repeatable read, and phantom read. Let's explain each of these problems very quickly. So lost update, what it means is, let's use this example, right? So let's say you have a table called reservations, and in this table you have 3 columns: flight, seat, and the passenger name. Now, one application is connected to this database and tries to access this table and issues an update statement where it's going to change the passenger name to instruct, where the passenger name is null, right? And the seat is 7C. So it basically is trying to change the first row here and it's trying to put here instruct. Now, the other application at the same time is trying to do the same, but now it's trying to change the passenger name to manager from this on this side. So what's going to happen, that if the first application was the one who performed the update first, and this was saying instruct, and then the second application comes next and does this update, then the final result would be that this would say manager. So basically we just lost an update from the first application. Now moving on to the next type of problem, we have uncommitted read. So what that means is, using the same example, I'm doing an update so that I want to update the first row, so that now the passenger name is instruct, but then comes the other application and issues a select statement where p name is null. So given that the first one now is not null because it's saying instruct, then it will only pick the second row, which is the one that has a 07B. But then what's going to happen is that the first application is going to roll back. So the change that it made for the first row, it's going to roll it back. So it's going to, it's not valid basically what it was doing. So it's going to roll back. And what's going to happen is that the second application basically has incorrect results because it just has one row when it should have two rows, right? So this is called uncommitted read. Then we move on to another problem, which is non-repeatable read. So in this example, we have the same reservations table, or actually this is another table, but it's related to the same theme on reservations of flights. And in this case, let's say I perform I obtain a cursor. So I basically do a select statement and I get several rows. Now what's going to happen if okay, so one application issues a select statement and gets, let's say, all of these rows that you see on the screen. Then another application comes in and performs an update or some sort of operation that will remove one of these rows from the cursor. So that means that when the first application issues the same cursor again, the same select statement again, he will see that there are less rows available or returned. So basically that's what is called a non-repeatable read. You cannot repeat the same result for the same read operation or for the same select operation or for the same cursor. The next problem is called phantom read, which is similar to non-repeatable read, but instead of reading less rows, you're going to read more rows, right? So for example, here you have the reservations table. Right now it says that application A is doing a select statement where p name is null, so it's going to get the first row. Then comes in the second application, which performs an update so that the second row where the p name is new, now it's going to be null, right? So the second row is going to be null. And then when the first application issues the same select again, opens the same cursor again, he or she will get more rows. He will get two rows now, the first one and the second one, because now there are two. Now both of these rows will have a p name of null. So this is called a phantom read, because in the first case when I open the cursor I only got one row. Now the second case I get two rows. Okay, so now moving on to the third session of this presentation, we're going to talk a little bit about locking in more detail. So locking allows for maintaining data integrity while still allowing for concurrency, and locks are taken automatically. So as you are performing operations, updates, inserts, deletes, then DB2 will take care about handling locks. There are two types of locks. There are locks for an entire table and locks also for rows. And also there are another classification in terms of types of locks is to have share logs and exclusive logs. Share logs are logs that are taken when you are performing maybe a read operation, and we just call it an S log. An exclusive log is maybe when an application is doing an update, insert, or delete. So that will be exclusive log. So that means that particular application can do things exclusively, and not all the application can work on the same row at the same time. Now within logs we have what is called an isolation levels. You can think of isolation levels as policies on how you want DB2 to work with the locks. So there are different isolation levels, and these are the names are similar to the problems that we were seeing before. So we have uncommitted read, or UR, also known as dirty read, cursor stability, or CS, read stability, or RS, and repeatable read, or RR. You can set these isolation levels at different levels. You can set it at the application level or session level, where the default is cursor stability. You can set it at connection level. You can set it at the statement level. If you are using embedded SQL, you can set it at bind time. For dynamic SQL, you can set it at runtime. So let's go through these isolation levels one by one, and you can pause this presentation and look at the information here, and you can see what type of situations can happen and situations that could be prevented as well. So if you move on to this next slide, you will see the same thing for cursor stability. You can again pause and you can read more about this, or the next slide for read stability, you can pause again and read more about this. The same for repeatable read. But now let's move on to this next slide, where I will explain these same isolation levels using this chart. So what we have here is, let's say you have a table on the left side, and you have, these are the rows of the table, and what you're going to do now is you are going to do a fetch operation. Now let's assume that your application is using UR, so it's using uncommitted read, right? So that means that as you're fetching, as you're going down the rows, no row log will be taken. Okay, so this is when you have an application with isolation level of UR. If you use isolation level of CS, what's going to happen is, as you are going down and reading from this table, you're going to take logs. So for example, here I'm reading the first row, so I'm going to take a log on the first row. Then I go down to the next row, and what's going to happen is I'm going to release the log on the first row, and I'm going to take a log on the second row. As I move down to the third row, I'm going to release the log on the second row and take a log on the third row, and so on and so on. Right. Now, with respect to RS or RR, what's going to happen is when you access the first row, I'm going to take a log. When I move down and I fetch or access the second row, I'm going to take a log on the second row, but I'm still going to keep the log on the first row. When I move down to the third row, the same thing. I'm going to take a log on the third row, and I'm still going to keep the logs on the second row, on the first row, and so on and so on. So as you can see, the first isolation level, which is UR, allows for maximum concurrency, while RRRS allow for the least concurrency. But at the same time, UR provides probably the least accuracy in terms of results, while RS or RR provide the most accuracy in terms of results. So that's a quick overview of how UR, CS, RR, and RS work in terms of locking. Now you can set, as mentioned before, the isolation level at the application. So this is an example where if you're using JDBC, you will set a property in the JDBC application for the different isolation levels. So if you set a property in JDBC for transaction read uncommitted, then when it reaches DB2, it will be translated to uncommitted read. When you set it to transaction read committed, it will be converted to cursor stability, and so on and so on. Something interesting here is that for JDBC, when you use transaction repeatable read, that doesn't translate to repeatable read in DB2, but to read stability. And when you use transaction serializable, then that one is what translates to repeatable read in DB2. If you have a .NET application, similar, you will get, depending on the property that you set in .NET, it will translate to different isolation levels in DB2. Now you can also set isolation at the statement level, and that is done simply by adding the term with and then the isolation level that you want to use. So for example, here you say with UR, and then that would apply to this statement. So what's going to happen is, let's say you can have you have a application that is using cursor stability in general, but for a specific statement you can use this with UR. So that for that particular statement we'll just use with UR, and we'll show you later a scenario of how that works. Next section in this presentation is log escalation. How does this work? Well, let's say you have many applications that are accessing a given table, and they will be taking logs on the different rows of the table. Now what's going to happen is each time you take a log on a row, you will be using some amount of memory for logs. So there's an area in memory called the log list, which is the logs, basically the area in memory for logs. And you know, as you take more and more row logs, you will be using up that space. So there will be a point where you run out of space in that area, and then what DB2 will do is it will perform an escalation of the logs. So from many small logs, it will escalate to one single table log. So that will not be good really, because let's say if you had 1 million rows and you were doing locking on the rows. Now let's say if you have 500,000 row logs, then at that time you have 1 million rows and you are locking 500,000 rows, then that's not good. But at the same time that you have the other 500,000 rows is still available for use, or other applications can use it. But if you take a table lock, then that means the entire table, the 1 million rows are locked. So that's log escalation in general is not good. And you can manipulate or configure escalation from not happening by, as mentioned before, taking a look at the log list, and the other one is the max logs. These are parameters from the dbcfg database configuration file, and you can basically change or increase the log list to increase the memory. You can also change the max log, which is a maximum percentage of the entire log list for one single application. And you can change the value of these parameters so that the log escalation doesn't happen. The other thing you can do is you can change your application, so maybe you issue more commits, and that way you will be releasing the logs as well, right? But log escalation in general is not something good, and you can detect whether there is log escalation by looking at a diagnostic file, the db2 which we will cover in more detail on the troubleshooting section. But if we look at the db2.log, you could see these SQL escalate logs. So that tells you there was an escalation, and this is the statement that caused the escalation, and this is the table where that problem happened. So using the db2.log, you can determine when there is log escalation. You can also use a log snapshot. Snapshots are a facility in DB2 which allow you to take a picture on your environment, and you could do it for different sections, but in this case it's just for logs. And with that, basically that's the end of what log escalation is. And again, log escalation is not good. You'll probably see a degradation in performance. So if you see a degradation in performance, take a look at db2.log and see if there has been an escalation, and if there has, then try to either commit more on your application if the logic permits for that to happen, or increase the log list or change the max logs. So moving on to the next section, we're going to now talk about log weight. What is log weight? Well, log weight is basically the case where there are two applications trying to access the same row maybe, and one of them is holding an exclusive log, for example, and the other one is maybe trying to do either also trying to get an exclusive log or a share log on the same row. So the second application will have to wait. How long will it have to wait? Well, that's determined based on this parameter called log timeout. Now, log timeout by default is set to -1, which means infinite wait. So that means the other application may have to wait forever. Okay. You could set probably log timeout to 30 seconds, and then that means after 30 seconds, the application will get an error message saying that there is a log timeout. You can also use a special register, which is current log timeout, and that's for a particular connection only. Okay, now we can move on to deadlocks, and at the end of this presentation I'm going to give you some demos as to how log weight works, as to using with UR, for example, for one statement, and also examples of a deadlock. So what are deadlocks? Normally deadlocks are situations that happen due to bad application design. That's what we're covering really this section on the application part of these e-learning courses, because the deadlock and these type of locking problems are normally caused by bad application design. So a deadlock will be explained with this example where we have user A that is holding the raisin bran or the cereal, and then we have user B that is holding the milk. User A will not release the raisin bran until he or she gets the milk, while user B will not release the milk until he or she gets the raisin bran. So that's why we have a deadlock in this situation. Deadlocks in DB2 are managed by the deadlock check time configuration parameter. Actually, what DB2 does is when there's a deadlock, DB2 will use an internal algorithm to pick one of the two applications that are causing the deadlock, and then it will say, okay, you based on my internal algorithm, you are going to roll back, and you are the other one, you're going to be allowed to continue. So the one that is going to roll back is going to get an error message saying that, you know, you got a deadlock and I had to roll you back, while the other one will allow to continue. Again, deadlocks are problems normally from design perspective. And in terms of best practices for working with locking, we recommend you to commit as often as you can, depending on obviously on the logic of your application. Depending on what you're trying to do, you could, for example, if you're trying to delete a large amount of data, you can use something like alter table activate not log initially with empty table, rather than doing a delete of, you know, just issuing an entire delete of the table. You can delete just batches, so whatever you just need, just delete what you need. You can set the log timer to 30 seconds rather than using it, than leaving it as default to infinite, and you can just retrieve what you need. Don't retrieve more than what you need. So those would be the best practices. So now let me give you some demos on the things that I've talked about, like log timeout, like isolation level, and deadlocks. Okay, so for this, I'm going to use an example where, let's say I have an application A, and I have another application B, and they are trying to access rows from this table, which is, let's say it's the employee table that is part of the sample database. Okay, so that's this employee table. There are many columns on the table. I only put two: employee number and first name. And we're going to use two rows in particular, so I haven't put more rows than that. But let's say application A is doing an update. So let's open as well two windows. So I go start, run, and I type db2cmd, and I'm opening one command window at the top. So let's say that's application A. Then I'm going to do the same thing here, run db2cmd, and I open another application B. And from Linux will be the same thing, but you can open two terminal windows. Right? Now from each of them I'm going to connect. So from application A, I'm going to say db2 connect to sample. So I'm going to connect to the sample database. From here I'm also going to connect to the sample database. So I have two applications connected, both of them to the sample database. Right? So the one at the top is application A, the one at the bottom is application B. Now what we're going to do, I copy this in to Notepad so it's easier for me to perform these operations. So from application A or command line processor window 1, I'm going to do the following. I'm going to say application A, I'm going to do an update, and I'm going to do an update on the row with a sorry for my writing here, but anyway, application A is trying to access or do an update on the row with an employee number of 50, and it's gonna, because it's doing an update, it's gonna take an X lock, right? An exclusive lock. Okay, now I'm gonna do that by running this statement. So I execute the statement, and note that I'm using the flag +C. That means do not commit. So for this particular application, which is the db2 command window, there are several flags, and the plus C means do not commit, because this this particular application auto commits. So I want to prevent committing because I don't want to release the logs, right? So I'm going to press enter, and the statement performs successfully and the log is held. So right now what we have is this application, exactly what you see, application A, which is the first command line command window, and it is taking the next log. Now what we're going to do is we're going to go to the other application and we're going to run an update, but on another row, which is row number 30. Right? So basically from application that you see, application B, we're going to do an update on this particular row. So we are also going to take an X log because I'm doing an update. Right, so we do an X here as well. Now let me run that from this window here, and I press enter, and as well I'm using the plus C, which means do not commit. So now I have two applications that did an update on different rows, and therefore I have exclusive and exclusive over here. Okay, so now the first thing we're going to look at is we're going to see a timeout situation. So from the command line window number 1, I'm going to run this statement, db2 plus C again, so I'm not auto committing, and issuing a select first name from employee where employee number is equals 30. So basically from the first application within the same transaction, because I'm not committed, that means it's the same, still the same transaction. What I'm doing now is I'm doing a select on this particular row. So basically I'm taking a share log here, right? Now because the application B was taking exclusive log on this row, then this other application A will have to wait, so it will hang in there. So let's see the behavior after I press enter here. So I press enter, and you see the prompt has moved to this side, to the bottom, right? So now it's waiting and waiting and waiting, and it's basically going to be there forever because as I showed you before, there is a parameter log timeout, which by default is set to -1, and I have not changed that. So that means it's infinite wait. So this is a timeout, and because log timeout was set to -1, it will wait forever. If I had set it to 30 seconds, then I will get an error message, right? Now I'm going to kill this select, and I'm just going to do a control C to interrupt. Okay, I'm going to interrupt this, control C, and I'm going to run the same query again, but I'm going to add with UR. And so basically for this particular SQL, I'm going to say that I want isolation with UR, because otherwise by default what is using these applications, what these applications are using, is cursor stability or CS. Okay, so it's the same scenario, but now I'm saying with UR, and I press enter, and look, I do get the result. Even though the logs are being taken, you see from this chart, even though there's an exclusive log over here, now I'm going, and when I use with UR, then there are no logs taken here at all, so these can go in and read the information. So there's no share log, and it can read the information. Okay, so that's a second demo, let's say, on using with UR for isolation on one particular statement. Now let me go back and remove this with UR and try again, and again you can see it will hang. Okay, so we're going to leave it like this, and now we're going to move on with example, but this time we're going to do a select, but on row number 50, and this is going to be done by the application B. Okay, so basically this application A, this application B, and now what we're going to do is from this application we're going to do a select on this row. Okay, on this row, and because we're doing a select, basically I'm trying to get a share log. I'm getting a share log here, but what I just caused is basically a deadlock, right? Because one application is waiting on the other one and for our resource, and application B is holding one resource, application A is holding the other resource. So what's going to happen is we just created a deadlock. So let's execute that SQL statement from this other window. I right click. Oops, sorry, let's do it again. Okay, and I'm going to press enter here, and what's going to happen is probably will take about 10 seconds or so, and then one of the applications will roll back and the other one will be allowed to continue. And you just saw that happening, right? The one at the bottom was rolled back, so application 2 or this application B was rolled back, and here is the explanation. The current transaction has been rolled back because of a deadlock or a timeout, reason code 2. And the other one was allowed to continue. So I got here the right result, which is the first name, which was Sally, for this particular employee number. So this is the other demonstration I wanted to show you with respect to deadlocks, and it took about 10 seconds because it's based on the parameter deadlock check time, which I mentioned to you before. And this parameter basically says, you know, if you set it to 10 seconds, it means that DB2 will check every 10 seconds if there is a deadlock. So every 10 seconds, is there a deadlock? Every 10 seconds, is there a deadlock? And so on and so on. So anyway, you can try and practice this scenario yourself. So let's move on with the next slide. And basically that would be the end of this presentation. So thank you very much for listening to this lesson, and congratulations because you completed the lesson. And as to what is next, you can continue with lesson number 12, which is SQL PL store procedures. Thank you and have a good day.